This lecture is on resonance. Resonance term used when electrons are delocalized. These are electrons that can be spread out over several atoms or bonds. Resonance structures involve at least two equivalent Lewis structures, but the placement of the electrons differ. Let's look at a couple examples. This example of localized pair of structures with the formula of XeBr2F2. In these examples, they have no movement of electrons because localized structures have electrons moving between atoms in that specific bond. In this case, electrons shared between Xe and Br and Xe and F can't move to any other region, but only between them. This example of delocalized pair of structures with the formula of O3. In this pair of structures, they have one pi bond, which can be spread out over a longer region, and as a result, the bond length of both OO bonds is an average between an OO single bond and an OO double bond. As a result, the ozone molecule is an average of both structures. How does one deal with drawing resonance structures? 1. After determining the total number of valence electrons, determine the central atom that is most metallic. Note, if an anion, add 1 electron per magnitude, and if a cation, subtract 1 electron per magnitude. 2. Distribute the electrons by making at least one pair of electrons between the central atom and terminal or internal atom. 3. If necessary, form double bonds by moving one pair of terminal or internal atom to the central atom to complete the octet. Note, if the central atom is located in group 5A through group 8A and located in period 3 or beyond, a possibility of an expanded octet is to be taken into consideration. 4. Bracket the structure if it overall has a charge and place formal charges for any non-zero atom in the Lewis dot structure. Comments of Lewis dot structures with relationship to formal charges. 1. Non-bonding electrons are represented as dots only accounted to the atom located. 2. Any bonding pair between any two atoms, single, double, or triple, are shared evenly between the two atoms. 3. Calculating formal charge is as follows. Formal charge equals valence electrons for the atom minus half bonding electrons minus non-bonding electrons. For problems asking you to select which structure is the major contributor, there are some things you must know. 1. The major contributor structure is the one with all the atoms having a formal charge equaling 0. 2. If you have any negative charges on an atom for a species who overall has a net charge, they should be assigned to atoms that are more electronegative. Similarly, any atom with a positive charge should be assigned to atoms that are less electronegative. Sample problem 1 is, draw all the resonance structures for CO2. Which structure are the major contributors? Here are the 3 Lewis dot structures of CO2. The first structure has a CO single bond and a CO triple bond. The second structure has 2 CO double bonds. The third structure has a CO triple bond and a CO single bond. All 3 structures have 16 valence electrons. The valence electrons for O, C, and O are 6, 4, and 6 respectively. The total number of electrons as described per structure from O, C, and O atoms are as follows. Left structure is 5, 4, and 7. Middle structure is 6, 4, and 6. and right structure is 7, 4, and 5. The formal charges from O to C to O atoms per structure are as follows. Left structure is +1, 0, and -1. Middle structure is 0, 0, and 0. And right structure is -1, 0, and +1. The major contributor of CO2 is the middle structure because all atoms are 0 in formal charges. This figure shows the formal charges of all atoms for the 3 resonance structures of CO2. Problem 2 is draw all the resonance structures for SCN-. Which structure are the major contributors? Here are the 3 Lewis dot structures of SCN-. The first structure has a SC single bond and a CN triple bond. The second structure has an SC double bond and a CN double bond. The third structure has an SC triple bond and a CN single bond. All 3 structures have 16 valence electrons. The valence electrons for SCN are 6, 4, and 5 respectively. After taking the total electrons as described per structure from S to C to N atoms, they are, for the left structure is 7, 4, and 5, middle structure is 6, 4, and 6, and right structure is 5, 4, and 7. The formal charges from S to C to N atoms per structure are as follows. Left structure is -1, 0, and 0. Middle structure is 0, 0, and -1. And right structure is +1, 0, and -2. It would appear that both the left and middle structures seem to be the major contributors to the Lewis dot structure of SCN-. The difference is where the negative charge is on. The left structure has a negative charge on the S atom, where the middle structure has a negative charge on the N atom. It turns out that the middle structure is the major contributor because N is more electronegative than S. Thus, N would prefer the negative charge over S. Here in this figure are the 3 resonance structures of SCN- with formal charges labeled. Here is a review exercise for you to try. Draw the 3 resonance structures of OCN-. Which structure are the major contributors? For the remaining part of this lecture are solutions to review exercise problems. Please view only after completing these exercises.